Hello everyone, welcome to AI Tools Research Channel. I am your host, Zed Badi. Today, we are introducing a new two-part series on real-time voice synthesis tools, specifically text-to-speech, TTS, synthesis. In the first part, we'll explain what real-time voice synthesis and text-to-speech is and the technologies behind this remarkable innovation. In part 2, we'll cover over 18 AI text-to-speech tools that are out there in the market. We'll discuss the tools and their pros and cons. So let's get started with the first part, which is the rise of generative AI and where text-to-speech synthesis fits in. As many of you may already know that the realm of artificial intelligence, AI, has witnessed a transformative leap with the advent of generative AI for text, which was made almost universal in a few short months after the introduction of ChatGPT in late 2022. Generative AI is a branch of AI that is reshaping how machines understand and interact with humans in our world in natural language that humans understand. Albeit, it's yet only English language and Chinese, but that is changing fast. This is because unlike traditional AI, which primarily focuses on understanding and interpreting data, generative AI takes this a step further by creating new content, be it text, images, audio, or video, because it has learned all that from the training it has received. That is what large language models, LLMs, are. LLMs are pre-trained mammoths, which have gobbled up tons of content that humans have been creating in the past centuries until now. The roots of generative AI can be traced back to the development of neural networks and deep machine learning. With the evolution of deep learning, AI models have become capable of analyzing vast datasets, learning patterns, and generating outputs that mimic human creativity and reasoning. This advancement in natural language processing, NLP, has opened new doors in numerous fields, from content creation to medical research. One of the most notable developments in generative AI is the creation of Generative Adversarial Networks, GANs. GANs involve two neural networks, a generator and a discriminator, working in tandem to create highly realistic outputs. This technology has been instrumental in generating lifelike images and videos, often indistinguishable from real-world objects. The surge of large language models, LLMs, like OpenAI's GPT series, PaLM, from Google Brain, Lambda, also from Google, Claude 2, from Anthropic, Llama, from Meta, and tons of other open-source models represent a major and significant milestone. These models use the transformer architecture, enabling them to generate coherent and contextually relevant text. Their applications range from amazing writing assistance to language translation, reflecting a deep understanding of human language nuances. Generative AI is not limited to just text generation now. Gen AI is making huge strides in the field of text to video, text to images, and text to speech synthesis. Advanced text-to-speech systems now utilize neural networks to produce speech that mimics real human voice, for use in a wide range of applications and domains. The rise of generative AI marks a new era in technology, characterized by machines not just learning from data but also creatively contributing to produce more content. As this technology continues to evolve, it promises to redefine the boundaries of AI capabilities, making machines more creative and intelligent companions in our digital world. Now let's delve deep in the realm of real-time voice synthesis. Real-time voice synthesis refers to the ability of a text-to-speech (TTS) system to convert written text into spoken words almost instantaneously, without any noticeable delay. In such systems, as soon as the text is input, the synthesized speech is generated and played back to the user in near real time. Key aspects of real-time voice synthesis include speed. The system processes and converts text to speech quickly enough that the listener perceives it as happening instantly. This is crucial for applications like live announcements, real-time translation, or interactive voice response systems where delays can disrupt the flow of communication. Fluidity. The generated speech should not only be quick but also fluid and natural sounding, without awkward pauses or robotic intonations, which can be challenging to achieve in real-time processing. Efficiency. Real-time systems are typically designed to be efficient in terms of computational resources, ensuring they can operate smoothly on various devices, including those with limited processing power like smartphones or IoT devices. Adaptability. These systems can often adapt to different contexts or use cases on the fly, such as changing the voice's tone, speed, or accent based on user preferences or specific application needs. Real-time voice synthesis is a significant advancement in the field of speech technology, enhancing user experience in numerous applications. From virtual assistants and navigation systems to assistive technologies for individuals with reading or sight impairments. So what is the technology behind this magic? How is just simple text converted to human-like spoken words? Well, text-to-speech tools use a combination of neural networks, such as LSTM networks, or long short-term memory networks. And more recently, end-to-end deep learning approaches like tachotron and WaveNet. These systems analyze text and generate corresponding speech waveforms that mimic human speech. Tachotron and WaveNet were among the leading technologies in the field of text-to-speech synthesis until recently. However, the field of AI is evolving so fast that many new technologies have emerged with amazing results. Let's discuss all these technologies mentioned and potential upcoming trends. Existing technologies. LSTM networks, long short-term memory networks. These are a type of recurrent neural network, RNN, used in earlier TTS systems. They are good at handling sequences, making them suitable for speech generation where context and continuity are important. While effective, LSTM-based systems are gradually being surpassed by newer neural network architectures in terms of naturalness and efficiency. Tachotron. Tachotron is an end-to-end generative text-to-speech model developed by Google. It simplifies the speech synthesis process by directly converting text to audio without intermediate steps. Tachotron and its successor, Tachotron 2, have been highly influential, but they are part of an ongoing evolution in speech synthesis technology. WaveNet. WaveNet was also developed by Google. WaveNet is a deep neural network for generating raw audio waveforms. It produces more natural and human-like speech compared to older techniques. WaveNet set a new standard for natural-sounding speech and has been integrated into various Google products, including Google Assistant. Now let's discuss some new and upcoming trends. Transformer-based models. Following the success of transformers in natural language processing, like GPT models, there's a growing interest in applying transformer architectures to TTS. These models could offer major improvements in speech quality and efficiency. Diffusion models. Inspired by the success of diffusion models in image generation, like DALL-E, Stable Diffusion, Mid-Journey, Leonardo AI, etc., researchers are exploring diffusion models' application in audio synthesis, including TTS. These models could potentially generate even more natural and diverse speech patterns. Personalization in voice cloning. Advances in AI are making it easier to customize speech synthesis to specific voices or styles, and even clone voices with minimal data. This raises both exciting possibilities and of course ethical considerations, like the problems we are already encountering with deep fakes. The cloned voices are so real that it is hard to distinguish real voices from fake, even by experts in the field. Cross-modal learning. These are systems that learn from both text and audio data, and even video, to generate speech that's more expressive and context-aware, matching speech patterns to emotional cues or visual contexts. Energy and resource efficiency. With the increasing use of AI models in various devices, there's a growing emphasis on making these models more energy efficient and capable of running on devices with limited computing power, such as mobile phones and common household appliances. One example is the concept of an LLM in the role of a supervisor or manager, invoking various AI models to empower a device when needed. Just imagine your refrigerator carrying on a conversation with you in your grandmother's real voice, or your automobile navigation device giving instructions in your dad's voice. That would be really cool. Here are a few key text-to-speech technologies that are competitive with Tachotron and WaveNet. Deep Voice, by Baidu. This is a deep learning text-to-speech model from Baidu that matches WaveNet audio quality using a fraction of the training data. Voice Loop, by Meta. Announced in 2022, this model from Meta efficiently learns speech patterns directly from raw audio and text without a large dataset. Koki, by Scary Lab. an open-source toolkit for building neural voice models using convolutional networks rather than recurrent networks as in Tacotron. Fast Speech, by Microsoft. From Microsoft Research Asia, this non-autoregressive model improves training speed and stability over previous autoregressive models. EATS, by Apple. Though details are limited, Apple utilizes an enhanced version of Tacotron called Ernst in production across Siri voices. Some key advantages these newer models have include better efficiency, smaller footprint, and more robustness compared to the groundbreaking but slower Tacotron and WaveNet architectures initially introduced by Google. Competition remains extremely fierce in high-quality real-time TTS for applications. So, these were some major trends in speech synthesis and TTS. It's important to note that while newer models like transformers and diffusion models and other creative multimodal approaches are emerging, existing technologies like Tacotron and WaveNet continue to be highly relevant and are often used as foundations for further innovations in the field. The future of TTS is likely to see a blend of these technologies, continuously improving the quality, naturalness, and versatility of synthetic speech. Before we wrap up, we want to share with you a list of features that we have put together that a sound AI text-to-speech tool should have. Of course, this is a high bar as it is unlikely that any one tool will have all these features. But as technology evolves, it is not unreasonable to expect most tools having these features. Naturalness. The voice should sound human-like, without robotic intonations. The speaking styles should be expressive emotional speaking styles and not robotic. This includes the choice of emphasizing specific words to be able to express a range of emotions like happiness, excitement, sadness, etc. Voice customization. This means options to modify pitch, speed, tone, accents and more. Pronunciation editor. The tool corrects pronunciation, emphasis, and pitch control. Both audio and text input support. This means to receive audio as input in addition to text and convert both to your chosen speech profile. Language and accent variety. The availability of multiple languages and regional accents. Large library offering. A diverse and large collection of AI voices across languages. Voiceover features. These are features for adding speech to videos. Integration capabilities. This means ease of integration with other software or platforms. Accessibility features. Support for users with disabilities. Scalability. The ability to handle large volumes of text efficiently. Add pauses. This is for when the user wants to give the voiceovers an even more human feel. Preview mode. This means to see results and apply changes without getting charged if pricing is by word or character count. The ability to scan documents and convert printed text to speech. And last but not least, an easy-to-use and friendly user interface. In the next part of this video series, we will share 18 AI text-to-speech tools that are out there in the market. Many of the companies do not share the exact technology under the hood. But we are assuming it a combination of the above technologies mentioned in this video. Thanks for watching. If you liked this video, please like, subscribe and share. Your support will empower us to bring you more meaningful stuff happening in the world of artificial intelligence.